Okay, so we have some predefined values, which is we want our motor to run for 10 minutes, which is 600 seconds, and our total mass is expected to be around 70 kg, with Brandon as the demonstrator and 10 kg for the chair. And our radius for the wheel is 3 cm. It may be changed to 5 cm later on. We have predefined our speed to be around 1 meter per second, and we have predefined the battery to be 11.1 volts because this can be found in our lab. I think so. And we can later on find the acceleration for our speed to be this, using this formula, and we want our motor to start from 0 meter per second and runs to 1 meter per second within 4 seconds, and for that we will be able to find our acceleration. Okay, next is the rolling friction coefficient. Okay, this is the worst case scenario, 0.01. Okay, that's about it for the predefined values. Now let's go to the very important equation. Okay, this is the top of the motor, and this is the torque done by the wheel. Okay, this is the wheel radius, and this is the force done by the wheel. When you use the top of the motor to minus away the torque produced by the wheel, you will get this thing. This is like your mass times acceleration, just that it is a angular thing. Okay, and okay, so now let's look at this thing. Okay, I is the inertial moment, which is half mr square for our case because ours is a wheel. This is a standard formula for a wheel shaped thing. So there are other kinds of equation for I, but this is for wheel. And how do we find the alpha, which is the angular acceleration, is by using acceleration over the radius of the wheel. And later on we will realize that actually these two things will multiply to get around 0, so it is quite insignificant for our project. Okay, now let's look at this part. Okay, what is F? F is like a force done by the friction, and F is actually the summation of F due to the static friction and the rolling friction. Okay, actually the static friction is just ma. I don't really know is it static friction or not, but it's n times a. Then you minus away the rolling friction force, which is to use your rolling coefficient to times the mg. Yeah, so that's how you can get your F. Okay, so we make top motor the subject, and you should get this using this, and you know that this is insignificant, so you should get this equals to this top motor equals to force times wheel radius. Okay, so now top motor, but we are using both legs, so divided by 2 we will get this torque per leg. This is the important thing. Okay, now let's go on to finding the let's go on to finding the power and energy. Okay, we know that power is current times voltage, and actually this is also equals to force times velocity. So this part is actually the conversion from mechanical engineering to electrical engineering. So you may want to emphasize on this NE relationship. Okay, just now we found the force, and we know that our velocity is 1 meter per second, so we are able to find our power using this. And next, why do we need this power? Because we want to find the amount of energy that we need to drive our whole system, and this can be done by using this equation. Energy equals to power times the duration, because power is joules per second, so we will times amount of seconds in 10 minutes to get energy, and this is the energy that we need for our whole system. And from this we know how we can choose our battery. because it is governed by this. Energy of a battery is equals to the AH rating times the voltage, which we chose to be 11.1 volt, and times 3600 seconds. Okay, why do we times 3600 seconds is due to this AH reading. We have to do it for 1 hour. AH is not current times hour. It has another meaning, so that's why we need to times 3600 seconds. And after that, we should be able to get, we need to get the energy, battery's energy to be equals to the needed energy, and that's how we can confirm our power. Okay, next we need to choose our motor. Okay, now let's go back to this. Okay, this is actually the governing equation for the torque also. So torque equals to power over omega, which is the angular velocity. Okay, using the battery that we chose, we are able to get the power, which is IV, and we have the torque value, so we are able to find the omega that we need. Yeah, and now let's go to this omega equation. Okay, omega equals to RPM divided by 60, and inside the spec of motor, we're actually trying to choose rotation per minute, and we know that omega is actually rotation per second, so we will use omega to times 60 seconds to get our RPM, and that is the omega that we need. That's the RPM that we need using our battery. And we can also counter check using the formula on top of the video now, which is RPM equals to velocity times time to get the total distance within 60 seconds, and divided by 2 pi r, which we will get the number of rotation per minute. Yeah, I guess it is just 2 ways to finding an RPM. Yeah, anything I will clarify with you later on, but for now this is what we need. So yeah, okay, bye bye.